In this lesson, we're going to recognize characteristics of a graph of a polynomial function. We're also going to use the degree and the leading coefficient to determine the end behavior of a polynomial function. The end behavior of a polynomial function depends on the sign of its leading coefficient and whether the degree of the polynomial is even or odd. Recall that to find the degree of a polynomial, all you have to do is look at all the terms within the polynomial. Look for the term that has the highest degree, and if that degree is even, then it's an even polynomial. If that degree is odd, then it's an odd polynomial. An even degree polynomial, you will know that because an even degree polynomial not only will have an even number for its degree, but the ends of the graph on both ends will either face upward, a rise, or they'll face downward, a fall. And it's going to be that leading coefficient that determines that. If the leading coefficient is a positive number greater than 0, then the graph will, both ends will face upward. Both ends will rise. However, if the leading coefficient is a negative number, then both ends of the graph will fall. Now, the little dash that you see in between, that just represents that in between those two ends, you can expect some turning points in there. And recall, to find the number of turning points you can expect, it's always going to be n minus 1. Let's talk about odd degree. For odd degree will have like an S-type shape. And the graph will move from left to right in an upward motion, rising up, or it will move from left to right in a downward motion, falling down. If the coefficient of the leading term is a positive number, a number that's greater than 0, then it's going to move from left to right in an upward motion. It will rise. And if the coefficient is a negative number, then it will fall from left to right in a downward motion. In this example, you're asked to determine whether the graphs below represent an odd degree or an even degree polynomial. So recall that an odd degree polynomial has like an S-shaped pattern where it is going to be up on one end and down on the other, versus an even degree, both ends will either be facing upward or downward. So what would you say number 1 is? If you said odd, that is correct. Number 2, yes, odd as well. Number 3, notice number 3, both ends are facing the same direction, so number 3 is an even. 4, yes, 4 is even as well. 5 is odd, yes, notice that both ends are opposite ends. And 6 is even, that is correct. Good job. Graphs of polynomial functions. In this example, we're asked to graph the function f of x equals x to the 4th power minus x squared plus 5x minus 4. Now, before we identify the graph, let's look at some characteristics of this polynomial function. So here is the given polynomial function. We are first asked what is the leading term. So if you look at all the terms of your polynomial, the leading term is the term that has the highest degree. So out of all these terms, the term that has the highest degree would be the first one, the one that's up front, and that is x to the 4th power. That is the leading term. What is the degree of that leading term? Yes, the degree of that leading term is 4. 4 is an even number, which means this is an even polynomial. And recall, with even polynomials, the end behavior of the graph, you're going to have both ends either open up like as a rise up, or both ends will fall down, will point downward. So what determines it? Well, it's actually the sign of the leading coefficient that determines that. So because the sign of the leading coefficient is a positive, that indicates that both ends of your graph will rise up, and so then the graph then would be choice C. In this example, we're asked which graph matches the function k of x equals negative x to the 7th power plus x minus 4. Before we identify the graph, let's look at some characteristics of the given function. So first, we want to identify what is the leading term. So recall the leading term. You look at all of your terms of your polynomial, and the one that has the highest degree is the leading term. In this case, it's going to be negative x to the 7th power. What is the degree of that term? 7. 7 is an odd number, so therefore this is an odd polynomial. Recall, odd polynomials will have an S shape, so we can automatically cancel out the graph choices of A and C because it cannot be that, because this is an odd polynomial. So to determine whether it's B or D, as to whether your graph from left to right is going to rise up or whether it's going to fall from left to right, that's going to depend on the sign of the leading coefficient. And what is the sign of the leading coefficient? Well, as we can see, the sign of the leading coefficient is a negative sign, which means this is going to be a graph with an end behavior that from left to right will fall. So therefore, that would match choice D. In this example, we're asked which graph matches the function g of x equals negative x to the 6th power plus x squared minus 3x minus 4. Now, before we identify the graph, let's identify certain characteristics of this polynomial function. So starting with what is the leading term. So of the given function, you're going to look at all the terms, and you're looking for the term that has the highest degree. And in this case, that's going to be negative x to the 6th power. What is the degree of that term? The degree of that term is 6. 6 is an even number, so this is an even polynomial, which means that we can cancel out the choices of B and D, the S shape, because it cannot be that. So now we just have to determine, we know it's going to have an end behavior, whether it opens upward or downward. That's going to depend on the sign of the leading coefficient. And what is the sign of the leading coefficient? As you can see, the sign is a negative, which means that this graph is going to be falling downward or facing downward, which means that is choice A. In this example, we're asked which graph matches the function h of x equals 3x cubed minus x squared plus 2x minus 4. Before we identify the graph, let's look at certain characteristics of this function. So the given function here, we're asked what is the leading term. So of course, you're going to look at all of your terms to see which term has the highest degree. And in this case, the highest degree is 3x cubed. What is the degree of that leading term? The degree there is 3. 3 is an odd number, which means this is an odd polynomial, which means choice A and C we can cancel out. There's no way it can be choice A or C. So to determine which graph is it, let's take a look at the sign of the leading coefficient, because that's going to tell us whether that graph from left to right is going to be moving in an upward motion or a downward motion or fall. So the sign of the leading coefficient, as we can see, is a positive. So that means with the end behavior, this graph is going to be moving from left to right in an upward motion. In other words, a rise. And that would be choice B. In this example, we're asked to describe the end behavior of the graph of the polynomial function f of x equals 9x to the 6th power minus 3x to the 4th power plus x squared minus 2. So again, we want to look at the leading term. Our leading term here is 9x to the 6th power. The degree of that leading term is 6. 6 is an even number. Remember, even polynomials will either face upward or downward, so that means we can automatically exclude A and B. It cannot be A or B. Next, to determine whether it's going to face upward or downward is the coefficient of the leading term that will determine that, and since that number is positive, that means that it is going to open upward and be a rise, which is choice D. And there you have it, in behavior of polynomials. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.